First topic that we learn about in Unit 2 is slope. Now, slope is the measure of the steepness of a line. And the line we're talking about is going to be on a linear equation, or just a graph that is a straight line. And there's four types of slope. The first is positive. Positive is where we have a line that rises from left to right. It would look something like that. We're going uphill. A negative slope would be a line that falls from left to right, so we're going downhill. The third would be zero slope. The zero slope is just a horizontal line. So it's a flat line, there is no slope, so we call it a zero slope. The fourth is undefined, and that's a vertical line, so it's straight up and down. There's no way for us to determine how steep that line is because it's straight up and down, so we call it undefined. Now, some of you might have seen the sign in my room that has hoi vux on it, and this is what that stands for. H stands for horizontal. The O is really a zero, stands for zero slope, and the Y is for my equation. So if I had Y equals 7, that means my line or my graph is just a horizontal line through 7. Hoi. And then vux stands for vertical, undefined, x equals a number. So if I had x equals -4, that's just a vertical line through -4. Those are our four types of slope. We have two ways to find slope. The first is by using the slope formula. When we would use the slope formula is when they just give us a couple points that are on this line. Example 1 through 4 show us examples that we're going to use the slope formula to find the slope between these 2 points, or the slope of the line that these 2 points are on. And this is the formula. M is our variable for slope, and we say M equals y2 minus y1 divided by x2 minus x1. So what this means, we have 2 points. So this is the y-coordinate from our second point minus the y-coordinate from our first point. It doesn't matter which point is point 1 and point 2 as long as we decide which point is point 1 and which one is point 2. Then this is our x-coordinate from our second point and our x-coordinate from our first point. So what we have to make sure we do is that y and x, these x and y's, that's from the same point. And this x and this y are from the same point. We can't mix those up. The second way to find slope is by just looking at the graph. So if they gave us a line that's already graphed for us, we can do what's called rise over run. We could find 2 points that are on that line, and we go from one point to the other. We would go up or down first, that's rise, and then we'd go right or left, that's the run. So we'll see 4 examples of that on a graph in just a minute. But let's look at these examples right here. Example 1 I've kind of already done for us. So it wants us to find the slope of the line that these 2 points are on using the slope formula. And here's our formula right up here. The 2 points are 3, 9, and -5, 3. So what I like to do is go ahead and label this as x1, y1, x2, y2. Now we know which numbers we can substitute in for our formula. So here's our general formula, m equals y2 minus y1 divided by x2 minus x1. So now I start plugging in my numbers. So I look for y2, that was right here. So I put 3. Minus y1 was 9, so 3 minus 9. Then I go to my x-coordinates. x2 was -5. Minus x1 was 3. So 3 minus 9 is -6. And -5 minus 3 is -8. Now I have a positive over a positive. Well, a positive divided by a positive would give me, I have a negative over a negative. And a negative divided by a negative would give me a positive. So I could say that my slope, or m, equals 6 over 8, or if I reduce that, these are both even numbers, so I could divide them both by 2. 6 divided by 2 would be 3, and 8 divided by 2 would be 4. So I could say my final slope is 3/4. So what that means is it's a positive slope, so my line is going uphill. And I could plot one of these points, and once I do that, from that point, I could rise 3, and I would run 4. Since this is a positive 3, that means I'm going to go up. And since this is a positive 4, that means I'm going to go to the right 4. So I could keep adding points to that line as many times as I wanted to. Up 3, right 4, up 3, right 4. Let's look at example 2. Let's label our points. x1, y1, x2, y2. And we'll look at our formula. M equals y2 minus y1 over x2 minus x1. And now we can substitute in our coordinates. 4 is y2, so 4 minus y1 is 2. 4 minus 2. x2 is negative 5 minus x1 is 2. I'm going to write this down here. So equals 4 minus 2 would be 2. Negative 5 minus 2 would be negative 7. Can't reduce that. I only have one negative. So I could say that this is my final slope. And I could write this as m equals negative 2/7. So notice that my slope was negative. So when I graph that, or when I see this line, my line is going to be falling from left to right, or it's going to be downhill. So if I was to plot this, I would just give the negative to either the 2 or the 7. So if I give it to the 2, I'm going to go down 2, right 7. Down 2, right 7. Or if I gave the negative to the 7, then I could go up 2, left 7. They're both going to result in negative slope. Let's look at example 3. Let's label our points. x1, y1, x2, y2. Let's look at our slope formula. M equals y sub 2 minus y1 over x2 minus x1. And plug in my coordinates. y2 is 7, so I get 7 minus 7. So we're going to have something different here. And then x2 is 2, x1 is 5. 7 minus 7 is 0. 2 minus 5 is negative 3. So if I have 0 over negative 3, we could say, how many negative thirds do I have? Well, I have 0. So anytime I have 0 in the numerator, this will be a 0 slope. So m equals 0. So this will be a horizontal line. It'll be our third slope here, a 0 slope. Last example with the slope formula. x1, y1, x2, y2. Put my formula here, m equals y2 minus y1 over x2 minus x1. Now I can plug in my numbers. y2 is 4. y1 is negative 2. So that's 4 minus negative 2. So that's going to end up being 4 plus 2. So I'll write this right here, negative 2. But if I'm subtracting a negative, then those can both turn to positives. And then I would have 1 minus 1. So now I'm going to have 4 plus 2 is 6, but 1 minus 1 is 0. So notice the difference. On example 3, I had 0 in the numerator. That's a 0 slope. If I have 0 in the denominator, this fraction does not make sense. I have 6 zeroths. That doesn't make sense. This is what we would call undefined. So if ever I have 0 as my denominator, I just write the word undefined. That means that that slope is going to be a vertical line. So here's our 4 examples for the slope formula. That's one way we use to find slope. The other way that we use would be graphs. So if we have graphs that are given to us and they want us to find the slope of each line, then we have some points on the lines here, and we're going to use rise over run. So I'm going to go from one point to the next point by either going up or down first, that's rise. Then I'm going to go right or left, that's the run. But if we notice here, this graph is going uphill, so my slope should be positive. This graph is going downhill, so my slope should be negative. This graph is straight up and down, so that should be an undefined slope. And this graph is a horizontal line, so that should be a 0 slope. So let's go back and look. Our first graph up here, we have a point here and a point here. So it doesn't matter where I start. I'm going to start right here, and I'm going to go rise over run. So I'll zoom in here so we can see a little bit better. So I start here. And do I need to go up or down to get to this point? I need to go up. So I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I went up 14, or I rose 14. And I'm going to go right 1, 2, 3, 4, 5, 6, 7, 8. So I would write that as rise over run. So it would be 14 over 8. And I want to leave that as an improper fraction because that tells me to go up 14, right 7. Now I could reduce that if I wanted to. I could divide them both by 2, and I could say that that would be 7 over 4. And that would be my slope. I don't want to write it as a mixed number because that doesn't really help me with rise over run. Notice they're both positive, it's going uphill, so that's kind of a way I could check my work. All right, let's look at the next one. If I start at this point, I am going to go up, which I did on this example, but I'm going to go left, and left is going to result in a negative. So let's do that. I'm going up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I went up 10. I'm going to go left 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that would be a negative 12 because I went to the left. So rise over run, I have 10 over negative 12. Now I could reduce that. I could divide them both by 2. And I would get 5 over 6, and that is negative. And I should be able to check that. If it's negative, my line should be going downhill, and it is. So here's my positive slope, rise over run, and my negative slope, also rise over run, but we have a negative. Now down here, this is a vertical line. There is really no way for me to go rise over run because it's not running. It's not going to the right or to the left, so I'm only rising. So I rise, but I never run, so my run would be 0, which means I would have a number and my numerator. So this would be rise. However, I would have a 0 run. I don't run right or to the left. So remember, anytime I have 0 in the denominator, my slope is undefined. Vertical line, undefined slope. The last one is going to be a 0 slope. It's a horizontal line. So I'm never rising. So I rise 0, but I'm continuously running. So it's 0 over the run. And since I have 0 in my numerator, this would be a 0 slope. So these are our 4 examples of slope. Positive is uphill, negative is downhill, undefined is a vertical line, and 0 is a horizontal line.